Short circuit evaluation. Before we look at the notes, let's start with this question. What is false and true? Well, false and true, the AND operator is going to return true if they're both true. They're not, so it's going to return false. And sure enough, there's false. Okay, so what about false and false? Still false. What about false and x? Only I'm not going to tell you the value of x. It could be true, it could be false. And it turns out, naturally, you'll say, well, it's going to be false no matter what, because false and anything is false. This is true, it's correct. And so Python, knowing that, when it sees false and something, doesn't even evaluate that thing. It just returns false immediately. And this turns out to matter. This turns out to be a very helpful feature. It's called short circuit evaluation. So when you're evaluating this AND right here, Python will call this no function, which returns false, and then it will not call this crash function because it's short-circuited. False and anything is false, so it just returns. Now crash is a function you probably don't want to use in practice because it divides by 0 and just crashes. It's here to demonstrate a point. So this line of code does not crash because it does not call the crash function because it's short-circuited after calling no. On the other hand, on the next line, all we did is reverse the order. Instead of no and crash, we did crash and no. And sure enough, this line is going to crash because it calls crash and immediately crashes. So when we run this, we see that the first line printed false, and the second line here, line 11, went ahead and crashed with division by 0. If we get rid of this line, we'll see yes and crash, unlike no and crash, will crash because yes returns true. True and, well, now we can't short circuit. We need to evaluate the second operand to determine the result of the AND operator, and we will crash in that case. And sure enough, we see the first one still works and the second one crashes. That's short circuit evaluation. You could also short circuit with OR instead of AND, because once you have a truth value with OR, you know it's true. Short circuit with OR is not commonly used, but short circuit with AND actually is more commonly used. This example shows again how this works, but really where short circuit with AND is used is in a case where you'd say you're somewhere in your code and you say if, for instance, some variable I is an index into a string, say, and I say like I is greater than 0 and greater than or equal to 0. And I is less than the length of the string. If all of that's true, and s of I, the ith character of the string, I don't know, say like equals q. Okay, so now this is actually a common use of short circuit evaluation. The reason is, oh, by the way, we're totally ahead of ourselves talking about strings, but you should know why this matters. The reason is, right here we're asking if the ith character of that string is q. Which is great, except if there is no ith character, if I is 20 and the length of the string is 10, this crashes, and you don't want your code to crash. So what you do is you say if I is legally in range and the ith character is q, proceed. And this is where short circuit evaluation helps us, because if I is out of range, this will simply return false, and then we'll short circuit and we'll never even evaluate this code. And it'll simply act the way we want it to act. This is a very common usage of short circuit evaluation, which we'll run into in the near future.